Let's take a look at homework 5, number 5. They're asking us to find the derivative of a function using the rules of differentiation. And the function that they've given us is f of x equals 5 over x cubed minus 4 over x squared minus 1 over x plus 130. And we need to use rules of differentiation. And you might be thinking to yourself at this point, if you're just hitting this in the homework right now, my rules of differentiation didn't say what to do if I have an x in the denominator. We didn't talk about fractions. How are we supposed to differentiate these guys? What rule works? Well, the first thing you need to remember, and if you've watched the video for question 3, you know this already, but it can't hurt to go over it again. I want you to remember this about exponents. If you have something like in this particular exercise, we've got 5 over x cubed. So we've got this exponent in the denominator. We can bring that x cubed right up into the numerator. So we could have 5x. You want that x cubed, but once you bring it up from the denominator, you're going to need to change the sign to a negative. So basically, you can bring that x cubed up, but you need to change it to an x to the negative 3. But now everything's in the numerator, and we don't have to deal with any sort of fractions or worry about what's going on downstairs in our fraction. And that's going to make it a lot easier to apply the chain rule. So let's do that. We need to apply the chain rule. So we have f of x equals 5 over x cubed minus 4 over x squared minus 1 over x plus 130, and we need to find f prime of x. Well, first let's rewrite f of x. Let's get all of those exponents up out of the denominator. So we just said that 5 over x cubed is the same as 5 times x to the negative 3. 4 over x squared, we're going to bring the x squared up, but change the sign. That will give us 4x to the negative 2. For this one, we've got an x to the first power. Even though it's not there, that's what it means. We're just multiplying x times itself one time. And so we're going to bring that up. We have a 1 up here, so we really don't even need to rewrite that. It's just going to be the same as x to the negative 1. And then plus 130. That's kind of just tagging along for the ride there. Now we've got something that we can use the power rule on. So let's do it. F prime of x equals. And we start by multiplying the exponent times whatever this coefficient is here. So negative 3 times 15 is negative 15. And then we need to subtract 1 from the exponent. Now remember, this is a negative number, so negative 3 minus negative 1 is negative 4. You might be tempted to write a negative 2 there because you're thinking 3 minus 1 is 2, but we're subtracting 1 from a negative number, so it's actually going to be negative 4 in this case. Let's do the same thing here. Negative 2 times negative 4. Well, that's actually positive 8. And then we need to subtract 1 from the exponent. So negative 2 minus 1 is going to be negative 3. In this case, we're taking the negative 1 and multiplying it times the coefficient. Remember, there's kind of a 1 out here. We don't usually write it, but it's there. So this is negative 1 times negative 1, and I'll kind of put that 1 in there so that we can see it. Negative 1 times negative 1 is positive 1. And then x to the, well, we need to subtract 1 from the exponent. So negative 1 minus 1 is minus 2. And then no power rule here. We're just doing the constant rule, my favorite rule of differentiation. And that just says that if you've got a constant, the derivative is 0. So we don't have to put anything else. And it turns out that this is the answer to our question. It's actually negative 15x to the 4th plus 8x to the, or negative 15x to the negative 4th plus 8x to the negative 3rd plus 1x to the negative 2. And you don't have to write that 1 if you don't want to, but if you do, it's not going to be wrong. And so if you have any questions about this, if something didn't make sense, if you don't know why I multiplied or subtracted the way I did, if you need a little bit more help remembering these rules about exponents, shoot me an email and I will get back to you with whatever help you need.